All right, so the first one is number 44. And the title is Included. And included is just a fancy word that means in between. So that's the short answer to what included means. But I want to show you some pictures to say exactly what I mean by included. So here's a triangle, A, B, and C, and then here's an angle, angle 1. Okay, so I want us to emphasize this side of the triangle and this side of the triangle. So if you're looking at those two sides of the triangle, then this angle is between those, right? You see how this angle is in between those two sides? So we say that angle 1 is included because it's in between. It's included if you're looking at side AB and side AC. And then also you can have a side that's included. So there's another triangle. And this time I'm going to emphasize this angle and this angle. And if you're looking at those two angles, then this side is included. This side is in between the two angles. DF is included in this picture. If you're focusing on angle D and angle F. So included just means in between. Here the side is included because it's between two angles. And then in this picture, the angle's included because it's between the two sides. But the short answer is included just means between. Okay, so that's all on number 44, and then here's number 45. Yesterday we were proving that triangles were congruent, right? And it was a pain. The reason it was a pain is we had to show that this side was congruent to that side, and this side was congruent to that side, and this side was congruent to that side. And then we had to show that this angle was congruent to that angle, and that angle. We had to do 6 things, right? All 3 pairs of sides, and all 3 pairs of angles. So that's why the proof that we did was so long. Because we had to prove that all 6 things were congruent before we could know that the triangles were congruent. So it turns out that there are some shortcuts. So that's really good news, because today the proofs are going to be shorter. Okay, so this is shortcuts to prove triangles congruent. So the first one says, if all three pair of corresponding sides are congruent, if all three pair of corresponding sides are congruent. So let's say we were trying to figure out if this triangle was congruent to this one. Then we could measure this side and measure this side and see if it matched up. Let's say it does. And then we could measure this side and measure this side and see if those pairs matched up, if that pair matched up. And let's say it does. And then let's say this side matches up with that side. So we have three pair of sides that are congruent. It turns out that if that's true, then automatically this angle is going to be congruent to that angle. And this angle is going to be congruent. So you don't even have to check the angles. Because if the sides are congruent, then automatically the angles are going to be congruent. So if all three pair of corresponding sides are congruent, then the triangles are congruent. So that's really good news because that cuts our work in half. Yesterday we had to write down 6 different things, all three sides and all three angles. Now today we're learning that the 3 sides are enough. Now I have to do one day of the painful way because otherwise people don't understand what congruent triangles are. Congruent triangles are when everything matches up. All right, so this shortcut we abbreviate it SSS. And that means that there's one pair of sides that's congruent, and then a second pair of sides that's congruent, and then a third pair of sides that's congruent. So that's what SSS stands for. Okay, then also, if 2 pair of corresponding sides so this shortcut only uses 2 pair of sides and the included angles. If 2 pair of corresponding sides and the included angles are congruent. So this time we measure this side, and we see that it matches up with that side. And then we measure this side, and we see that it matches up with that side. And then we use our protractor and measure this angle and see that it matches up with that angle. It turns out you don't have to measure this side and that side because automatically they'll be congruent. You don't have to measure that angle and that angle because automatically they'll be congruent. So if you have 2 pair of corresponding sides and the included angle congruent, then that's enough to prove that the triangles are congruent. And we abbreviate this one side angle side. So this means that you have 1 pair of sides congruent for that S, a second pair of sides that's congruent for that S, and then a pair of angles that's congruent. And notice that the angle is in between the 2 sides. So that's emphasizing that it has to be included. It's only this shortcut only works if the angle is in between the 2 sides. Okay. That's it for no cards. So of course, you need a sheet of paper, please. I'm going to start with number one. Here's the picture for number one. Okay, so we're trying to figure out if that triangle is congruent to this one. There's two separate triangles in the picture. So notice that they told us that this side is congruent to that side, so that's one pair of sides that's congruent. And also they showed us that that side's congruent to that side, so that's two pair of sides congruent. And then they also showed us that that angle is congruent to that angle. So is that enough to prove that the triangles are congruent? It is, good. So we're going to write that down. Triangle ABC is congruent to triangle Now you have to be careful about how you write things down, right? So you'd have to take this triangle and rotate it. You see how that would rotate to there? So A matches up with D. Since I put A first, I have to put D first. So triangle ABC is congruent to triangle DEC because of the shortcut side angle side, right? Everybody doing okay? See where I got this stuff? Here's the next picture. So they marked that angle congruent to that angle, and they marked this side congruent to that side. So I'm looking at that triangle, and then that one. So far, they told us one pair of sides is congruent, and they told us one pair of angles is congruent. Is that enough to prove that the triangles are congruent? Good, that's not enough. One pair of sides and one pair of angles is not enough. You need 3 pairs of sides, or you need 2 pairs of sides and an angle, right? So far, we don't have enough. Okay, but is there anything else that these triangles have that's congruent? Yeah. Yeah, exactly. She's noticing that this is a part of both triangles, right? See that line? It goes with the top triangle and the bottom triangle. So I could put 2 marks on there because they're congruent by the reflexive property, right? Something has to be congruent to itself. So even though they didn't mark that, we know it's true. So now there's enough to prove that they're congruent by side angle side. So it is true that triangle GHJ is congruent to triangle IJH side angle side. Still trying to figure out if the triangles are congruent. They told me that these sides are congruent, so that's one pair of sides. They showed me those sides were congruent, so that's another pair of sides. And they showed me that these angles are congruent, so that's a pair of angles. So is that enough to prove that the triangles are congruent? I mean, it kind of fits this, right? Two pairs of sides and one pair of angles. You see how it kind of fits that? Two pair of sides and one pair of angles. Now, obviously, this triangle doesn't look like it's congruent to this, but we're supposed to go by the facts. Does side angle side work for this? Why not? Yeah, so you're saying you can tell that that angle is different than that one. Is that what you're saying? And the problem with what you're doing is you're going by the appearance of things. And I agree with you 100% that it appears that that angle is different than that angle. But we're not supposed to go by appearances. Because maybe this is just a quick sketch that somebody put down. Like somebody being me, right? But you're thinking awesome. So here's what I'm saying. I'm saying I think this is side angle side. Because isn't it kind of like that second shortcut? But no, you're thinking good. What do you think?
Well, how can you say that? Because that one's like rotated. So like.
Yeah. Okay, yeah, you're thinking good. So the problem here is that if side angle side was going to work, the angle would need to be up there. Because the angle has to be in between the two sides. The way it was right now, it was side angle, not side angle side. See what I'm saying? So that's why on the first note card, I made such a big deal about this word included. Because if side angle side's going to work, the angle has to be in between the sides. So here the angle is not in between the two sides. So that's why side angle side is not working. So this is not enough information. So the whole point of number 3 was side angle side only works if the angle is included, or in other words, if it's in between. And then the comment that you guys made was, yeah, obviously these triangles are not congruent. We just have to be a little bit careful and not go by appearances. Okay, here's the picture for number 4. We've got X, Y, Z, P, and Q. And this is marked as congruent to that. This is marked as congruent to that. And then this is marked as congruent to that. So we have this side congruent to that side, and that side congruent to that side, and that side congruent to that side. They don't tell us anything about the angles, right? So is that enough information to prove that the triangles are congruent? Yeah, what's the shortcut? Josh? Triple S, good, side, side, side. So we know that it's by side, side, side. That's the reason they're congruent. Now, what transformation will map this triangle onto that triangle? Yes, Scott. Good. See this line? If you reflect it across that. So when we write down our triangles, I'll go with triangle XYP. And when you reflect, you can see that X matches up with Z, right? Do you see how X matches up with Z? So since I wrote X first, I have to write Z first. So XYP and ZYQ. All right, now we're going to skip forward to number 11. And number 11 is a proof. But the good news is it'll be shorter than yesterday's because we have shortcuts today. And the given information is C is the midpoint of AE and BD. And there's a picture over here. We're trying to prove that triangle ABC is congruent to triangle EDC. That's our goal. That's what we're trying to prove. Trying to show that that triangle is congruent to that one. And what we have is this information, that C is the midpoint. Okay, so it says C is the midpoint of AE. Here's AE, and C's in the middle. So what does that tell us? Doesn't that tell us that this equals this? If that's in the middle, then that is equal to that. Make sense? All right, so I'm going to write down AC is congruent to CE. How do I know AC is congruent to CE? Because they said it was a midpoint, right? So this word was very important. So definition of midpoint. Okay, it also says that C is the midpoint of BD. So look at BD. That's that. So if C is in the middle between B and D, what does that tell us? BC congruent to CD, right? BC congruent to CD. Same reason, so I can put it in the same step. Okay, so I'm pretty close to proving that the triangles are congruent. So far I've got two pair of sides. That's not enough to prove that the triangles are congruent, right? two pair of sides is not enough. It'd be nice if there was a shortcut that was SS, but there's not. So we have to look at these two triangles and try to figure out something else that's congruent. So anything else you can tell that's congruent on these two triangles. What about this angle and that angle? Are they congruent? How do we know? Because they're vertical angles, right? And vertical angles are always congruent. Okay, so I'm going to mark that congruent to that, because I know that since they're vertical. And so then this one is ACB. See how that's called ACB? Trace it out. So angle ACB is congruent to angle DCE. Yes. When you name the angle, it doesn't matter. But I really like how you're thinking, because when you name the triangles, A has to match up with E, right? That's what you were thinking, and that's fabulous. But when you say DCE, that's the same angle as ECB. So those were congruent because it was vertical. So now that's enough to prove that the triangles are congruent. So now we know that triangle ABC is congruent to triangle EDC. And that's side angle side. So we know they're congruent because we had two pair of sides congruent and we had one pair of angles congruent. And then if we wanted to go, we're done because this was our goal, right? But we could go further and say, now we know this side is congruent to that side. Because if the triangles are congruent, then the corresponding parts are congruent. Or we could say this angle is congruent to that angle. And the reason for that would be CP, CTC, right? Once we have congruent triangles, which we just got, then we can go on and say the parts have to match up. Okay, one more. This is number 12. This is kind of out of nowhere. We're going to simplify the square root of 50. So what you do when you simplify a square root is you break it up into two numbers. So 50 is 25 times 2, right? I mean, it's also 5 times 10, but that's not as helpful. This is correct, but not helpful. This is more helpful because the square root of 25 comes out to 5. So if you typed 5 times square root 2 into your calculator, you'd get a big nasty decimal. And then if you typed square root 50 into your calculator, you'd get a big nasty decimal. But they're the same nasty decimal. We're just saying that this number is the same as that number. Just a different way to write it. I think you did some of this in algebra, so I think you kind of remember it. But if you need help on, there's one other one like that on the sheet, so if you need help, let me know.
I believe we did that like beginning of second semester.
Last year?
Yeah.
Okay. So yeah, it's been a while, so you probably don't totally remember. Next.